Hello Math Humans, we're going to do 2.2a today. We're going to be talking about basic differentiation rules. Our objectives are that we're going to find the derivative of a function using the constant rule, the power rule, and the constant multiple rule. So remember from the last couple of videos that we have done the limit definition of a derivative. And this gets to be rather tedious, especially as the functions become more complicated. So what we're going to do now is we're going to start learning the easier ways or all of the pre-established rules to help us find a derivative. So what I want to do first is talk about the constant rule. And I'm going to talk about it graphically before we do the math. So if I have a function and I have a horizontal line, it's going to look like Christmas because I got red and green pens. So let's say this is y is equal to a constant. Remember that the derivative is the slope of the tangent line. So it's the slope of the tangent line to the curve, function f. So if I have a constant function and tangent to a constant line is another constant line, let me see if I can get a different color pen, see if that'll show up. So tangent to the original function, the tangent line would be a horizontal function, and so the slope of a horizontal line is 0. So we would say that the derivative of a constant is 0. And notice that I didn't write dy dx because I'm just taking the derivative of a statement, not an equation, so therefore there's no y in the equation. So the derivative of a constant is 0 because the slope of a horizontal line is 0, therefore the slope of the tangent line is also 0. So then we would say that the slope of a constant is 0. So then the power rule is pretty easy. It says the derivative of something raised to a power, we bring the power out front, multiplied by this, and then it decreases by 1. So for a derivative, the power goes out front, and then the power decreases by 1. The next one is the constant multiple rule. And that one would be, let's say I want to take the derivative, and I have a constant in front of a function. Well, that means that the constant can be moved out front, and then I would take the derivative of the function. Okay, so it's really pretty simple. So now let's just do a series of examples. We have a nice short video today using the 3 different rules that we have so far. So I want to find f prime of x given f of x is equal to 3. So remember, this is a horizontal line, so that means that f prime of x is equal to 0. Okay, that was pretty easy. All right, next example. Example number 2. That was really pretty fast. I want to find, I'm going to tell you that f of x is equal to x cubed, and I want to know what is the derivative. Okay, so that's a 3, by the way, in case you can't read my crappy handwriting. By the power rule, f prime of x, the power goes out front, okay, and then this decreases in 3 minus 1, so this is just going to be 3x squared. And we could do the exact same process with the limit definition of a derivative, but holy cow, there's a lot more work involved. So we would say hallelujah at this point. Okay, example number 3. I have y is equal to 1 over x squared, and I want to find f prime of x. Okay, so those are my hieroglyphics for the problem that we're going to do. When we're taking derivatives, we're going to learn that we can do a different method called the quotient rule, but the quotient rule is a lot more entertaining. So I'm going to rewrite y as x to the negative 2 because now I can do the power rule. So f prime of x is going to equal, the power goes out front, here's the x, and then this decreases by 1, so this is a negative 2x to the negative 3. And so then I would write my statement, this is a negative 2x to the negative 3. You mean really so much simpler than doing the limit definition of a derivative. The fourth example, we're going to be given y is equal to 5 over 2x cubed, and I want to find f prime of x. Okay? And again, I'm going to rewrite this statement to make my life simpler, and I'm going to move the x cubed up to the top, so I'm going to have 5 halves x to the negative 3. So remember we talked about the constant is just going to stay, so f prime of x, the 5 halves, I'm just going to leave it alone. The negative 3 comes out front, x to the negative 4. And I'm not going to show you all the steps because at some point we will start to show less of the work. So it's a negative 3 minus 1, which is a negative 4. I'm going to clean this up. This is a negative 15 over 2, x to the 4th. I'm going to take this back down to the bottom. And I'm going to write that f prime of x is a negative 15 over 2x to the 4th. So just as in good math notation, we don't want to leave negative exponents because this is going to make the math later. Because remember, the derivative is part of the process, but we will use those derivatives later to do additional math. All right, your last example. Nice short video today. Holy cow, look at that. Example number 5. I want to find the derivative of 7 over 3x to the negative 2. Okay, so that says find the derivative of this statement. Okay, again, I'm going to rewrite it before I start. So I'm going to write d over dx of 7 over 3x squared, because I think that makes the math a lot easier. So now when I do the derivative, this is going to be 7 thirds. The 2 is going to go out front, x, and then 2 minus 1 is going to be 14 thirds x to the first. And remember that a derivative is decreasing in power, right? When we get to integration, the rules will be a little bit different. And then I write my answer, d over dx is equal to 14x over 3. You could write that as 14 thirds over x even. Either is appropriate. Alrighty, that is it for today. Under 10 minutes. What a deal. I will see you soon.